Hello, and welcome to a Reigate Maths video. This video is focusing on the linear programming chapter from the Decision 1 unit of the Edexcel Further Maths specification. My name is Simon, and in this video we're going to be looking at adapting our already looked at linear programming problem solution methods for what happens if our decision variables have to be integers. Now this is very, very common, because often our decision variables are things that you can't have a decimal number of. So, for instance, a type of tree. You can't plant half a tree. That kind of thing. So quite often you won't be told to do this. You'll need to know that this is what you need to do in terms of the context of the question. This question, though, that we're going to look at is not contextualized, but I'm saying that x and y must be integers. We can see we've got our objective function there, or our objective, maximize p equals x plus 2y. We've got our constraints, and then we've got our instruction. To recap what you've done in the previous videos, I'd like you to pause the video now and draw the graph and find the vertex of the feasible region which gives us the maximum value of p. You should find that it is not an integer value. Once you've got that, unpause the video and we'll look at how we find the integer solutions instead. If you haven't yet watched the videos for solving a linear programming problem, I'd advise you go back and do those now, and I've put links to the video in the description. So this is what your graph should look like. And these are the non-integer solutions. You can see I've written them as decimals because that's much more useful for the next part that we're going to be doing. I chose to use the objective line method, but you could have used the vertex testing method as well. So now what we have to do is consider the points around x and y. Now with this particular example, because the scale is not too bad, we can see which points are in the feasible region that we would want to investigate. However, in most situations, the scale is not going to allow us to do that. So we have to be a little bit more rigorous with what we write down. So much like when we did the vertex testing method, we're going to set up a table. And the first two columns are going to be x and y. The remaining columns are going to be the two inequalities. So 5y minus 4x is less than or equal to 10. And 3x plus 4y is less than or equal to 36. We're going to use these two columns to see whether the point that we're interested in is in the feasible region. If it's not in the feasible region, we don't need to do anything else. But if it is in the feasible region, we need to calculate our value of p. So that's our final column. The rows are going to be the points that surround 4.5 and 5.6. So we've got 4, 5, 4, 6, 5, 5, and 5, 6, which are these points here. Again, we can see from the scale of the graph that the points with the y coordinate of 6 are not going to be feasible, but it's harder to spot in a different graph. What we now do is we now put these points into our inequalities. So let's do this one first. So we've got 5 times 5 minus 4 times 4, which is 9, which is less than 10. So this one works for our first inequality, and we would expect that. That's this 0.45 here. We need to test in them all in the next one. So we can see we've got 3 times 4 plus 4 times 5. 20 plus 12 is 32, which is less than 36. So this point is in the feasible region, so we can calculate our value of p. And we get 14. If, for whatever reason, so we can see with this next point, the 4, 6, we get 5 times 6 minus 4 times 4. We get 30 minus 16, which is 14. That's not less than 10, so it doesn't work. So we don't need to calculate anything else. We don't need to check it in the other inequality because it's irrelevant. We don't need to calculate p because it's not in the feasible region. So we keep going. We can see that we've got 5 times 5 minus 4 times 5. So 25 minus 20 is 5 is less than 10, which is good. 3 times 5 plus 4 times 5 is 35, which is less than 36. So this one's in the feasible region. And so we get our value of p as 15. The final one, 30. Being careful because the orientation of this one is different. 30 minus 20 is 10, which is less than or equal to 10. Okay, remember the inequality is equal to, so that's fine. And again, we'd expect that because this point is on the line. Because it works, we still need to check the next one. 3 times 5 plus 4 times 6 is 39, which is bigger than 36, so we don't want it. Okay. Once we've got all this, we just pick the biggest value of p, like we did with the vertex testing method. So the maximum p is 15 at the point 5, 5. Again, if this is contextual, like we've seen in the past, then you need to conclude in context as well. Like I said at the start of this video, they might not tell you to do this in the question. But if the question is contextual and our decision variables x and y clearly have to be integer values, so if x and y are time, you don't need to do this because time can be decimalized. But if it's something physical or something that can't be separated into non-integer components, you will have to do this anyway. You might need to spot that you need to do it yourself. But otherwise, that's how you solve a linear programming problem with integer solutions. Thank you for watching.